All right, guys. Okay, this is Gideon again. Uh, in this video, we'll see grade 9 physics, linear motion. Okay, in this tutorial, we'll cover what linear motion is and what the types of linear motions are. The other thing we are going to cover is distance and displacement, the difference between distance and displacement, speed and velocity, acceleration and deceleration, the motion formulas that are going to be used to calculate distance in linear motion, scalar quantities and vector quantities, units and conversion of units. The other thing is we are going to be given a problem at the end of this session, and I will solve one problem, and I will give you another problem that you are going to solve, and we'll see graphs and the velocity time graph and how to solve distance or calculate a distance from the velocity time graph. So the benefits that you are going to get from this tutorial is strong concept understanding. You will understand what a linear motion is, the ability to solve exam problems, and skills in interpreting graphs. These are the benefits that you are going to get. So what is a linear motion? Linear motion is a motion in a straight line. So ማለት ነው ሞሽን በቀጥታ መስመር ላይ የሚደረግ ሞሽን in a straight line ይባላል ማለት ነው። For example, if a football player kicks a ball, that's not a straight line motion because the ball moves in vertical and horizontal direction at the same time. ማለት ነው በኤክስም በዋይም ዳይሬክሽን ሙቭ ያደርጋል። በከፍታ ሞድ ላይ ይሄዳል፣ በጎን ሳይድም ይሄዳል ማለት ነው። So that's not a straight line motion. So you have to differentiate what a straight line is. Just straight line motion is a motion in a straight line, not in two directions, just in one direction. It could be in X direction or in Y direction, or even in a Z direction. So sometimes you might be asked which one of the following represents a straight line motion or a linear line motion or rectilinear motion. Sometimes they call it rectilinear motion. So what are the types of straight line motions? The first one is uniform motion, that is a constant speed or constant speed motion. Uniformly accelerated motion, the velocity increase. And so if let's say the speed may be constant, but still that if there is a direction change, or for example, let's say a car is moving 3 meters towards east and starts moving 5 meter per second, 3 meter per second starts. If a car starts moving from right, starts uniformly moving 3 meter per second or 3 kilometer per hour towards east and changes direction towards north with 5 kilometer per hour, that means the direction is changed. Even though the speed without let's say not 5, even it's 3 kilometer per hour, you see the speed is constant, but the direction is changed. If the direction is changed, the velocity changes, because velocity is speed plus direction. So it was moving in its direction first, and when it's changed direction towards north, that means the velocity is changed. This kind of motion is called uniformly accelerated motion. The other type of motion is deceleration, that's negative acceleration. Let's say a car is moving in a straight line, and suddenly if it wants to stop and holds its brake, ወይም ደግሞ ብሬኩን ቢይዝ ወይ ደግሞ ፍሬን ቢይዝ እና ቢያቆም ዲሰሌት እያደረገ ማለት ነው። አክሰሌሬሽኑ እየቀነሰ ነው፣ ዜሮ እስኪመጣ ድረስ እስኪቆም ድረስ እንትን ይላል ማለት ነው። ስለዚህ so this kind of motion is called deceleration motion. So these are the three kinds of motions in linear motion. So you have to understand those things. The other thing you have to understand is distance. Distance is the total path. It is scalar. It is scalar, and is the total path that's moved by a car or something like that. Displacement, while whereas displacement is a straight line or changing vector. So displacement is a straight line or changing distance. That's the changing distance, not the total distance. I will explain this by some example if you want it. Let me explain this one moment. Here you go. Assume that a car moves this way and moves again this way. Then let's say this is 3 meters and this is 4 meters, and assume this is 90 degrees. What is the distance covered by this car when if it starts from point A, then B, C. Then a car moves from point A to point B 3 meters, and from B to 4 meters, and if it's 90 degrees, then the distance covered by this car is distance S is equal to 3 plus 4 meters, which is equal to 7 meters. Whereas displacement, this is the symbol for displacement, R on 8. Displacement is equal to the shortest distance, this one right here, you see, S. Not this one, but this one. See, that is in Pythagoras theorem, that S is equal to S square is equal to 3 square plus 4 square, which is equal to 9 plus 16, which is equal to 25. Then displacement is equal to 5. You see, square root of 25 is 5. So the distance covered by this car is 7, whereas displacement is, this is the shortest path, that is 5. Let me show you another example. Let's say you move 3 meters towards east, 1, 2, 3 meters towards west, 3 meters, and move again 2 meters, 1, 2 meters towards east. Then what is the displacement? The displacement is the shortest path that you moved. This is the displacement. That is 1 meter. That is 3 in the west minus again 2 in the east. That's 1 meter. Whereas the distance is 1, 2, 3 plus those 2. 3 distance is equal to displacement is 1 meter, whereas distance is equal to 2 plus 3, the total distance moved is 5 meters. Whereas the displacement is 3 minus 2. There is also, you see, the direction is you moved 3 in the west, 1, 2, 3, but when you come back towards the initial position, you subtract 2, that's 1 meter. So displacement is 1 meter. That is the distance you moved from the original position. The net distance, that is the displacement. That's how I understand it. And let's go and keep talking about the other thing is the speed. The speed is distance over time. This is scalar quantity. Speed is scalar quantity, while velocity is displacement over time. So this is vector quantity. It has direction, change in direction over change in direction of motion could bring change in velocity, so change in acceleration or like that. So speed is a scalar quantity, just use distance over time, but this velocity is displacement over time. Motion formulas. Those are the formulas that we are going to use to solve distance in linear motion. Velocity, this is V is indicates for constant, for uniform motion which has no acceleration for uniform motion, just the speed is equal to distance over time. And from this you can crisscross and find out distance. Distance is the speed is equal to distance over time. Thus distance is equal to velocity times or speed times time. Whereas for accelerated motion, v final or v indicates v final is equal to u indicates u is, whereas u is initial speed plus acceleration times time. A is acceleration and t is time. The other formula that you might use is s distance is equal to initial speed times time plus half times acceleration times time square. The other formula you might need to use, maybe use those formulas depending on the given that you are given to calculate in the problem. So those formulas you need to remember and choose which formulas you are going to use from the problem you are given. So distance is equal to average speed, that is velocity final plus initial velocity divided by 2 times time. This is average speed times time. So if you are given final speed and initial speed, the time that covered, and you are asked, if you are asked for distance, you use this formula. The other formula is velocity square is equal to velocity final square is equal to initial velocity square plus 2 times acceleration times distance. Or this could be written as, you can crisscross and or this is the same formula, but you can write distance is equal to final velocity square minus initial velocity square divided by 2 times acceleration. You can remember, you might not need to remember both, but if you have one of these formulas, you can crisscross or move one to the right to the left and find out the other. So these two formulas are the same. The other thing you have to remember is quantities. Quantities, scalar, magnitude only, vector, magnitude plus direction. Units. There are 2 types of units, the fundamental units and derived units. For example, mass, kilogram, and second are fundamental units, whereas meter per second square, meter per second is a unit for speed or velocity, and meter per second square is unit for acceleration. They are derived. You see, they are derived ones. Meter per second is using 2 fundamental units. Meter is a unit of fundamental unit for distance, and second is a fundamental unit for time. So combining those two, you will get speed. So speed is a derived quantity. So, and those are derived units. So derived units, fundamental, you have to understand those 3 things are fundamentals, but meter per second or meter per second square, whatever you use, combining 2 fundamentals is a derived units. So a quantity, if you ask which one of the following quantity is a derived quantity, if you know the unit of that, you write the formula. And for example, force, let me explain this thing. You see, let me explain this thing. Look, let me explain it here. Force is equal to mass times acceleration. You will learn this later, but now let me show you. The unit of force is Newton. Force is measured in Newton. Mass is measured by kilogram, and acceleration is meter per second square. This, if the unit of force is equal to mass times acceleration, force is, the unit of force is Newton, represented by N, and mass is kg times acceleration is meter per second square. See, when you see Newton is not a fundamental unit because it's derived from kilogram. This is fundamental units, fundamental, meter, fundamental, and second is also fundamental. It's derived from three. fundamental units, and it's derived. This is how derived means. So force is a derived quantity, not fundamental quantity. That's how you understand. Let's go on. The other thing is conversion. So sometimes you might be given you might be asked to calculate distance in kilometer per hour or in meter per second, and quantities of velocities or speed of a car or something might be given in meter per second or like that. You might be uh, asked to calculate distance in kilometer, but uh, so but velocity or speed might be given in meter per second. The time may be given in hours. So that time you have to bring the equation or convert everything with the same SI units. SI units are, for example, the SI unit of distance is meter, and the SI unit of time is second. The SI unit of uh, uh, yeah, the SI unit of actually when we express speed in SI unit, it's a meter per second. So for conversion, let me show you how to convert units. I think hold on 1 second. This is, I think, 0.278. Yeah, that's rather than using a calculator to 78. 1 kilometer, 1 kilometer per hour is equal to 1 kilometer is equal to, let's convert this kilometer per hour to uh, meter per second. 1 kilometer is equal to 1,000 meter divided by 1 hour is equal to 60 minutes times, when you convert the minutes to second, again 60. This is 1,000 divided by 3,600 meter per second, not meter per second. This second, this is meter. So you cancel this by this, and 10 over 36 meter per second. So 1 kilometer meter per hour is equal to 10 over 36 meter per second. That is 0.278 meter per second. That's how you convert. So let me erase something right here that you're not confused. So this is how you convert. So let's go ahead. Then the next thing is we are going to solve a problem which covers all the formulas that we stated in the chapter. So what our solved problem says is, example problem: a car accelerates at 2 meters per second for 5 seconds from rest. Remember, the word rest indicates the car started from zero speed or velocity. So rest means it started from stopping position. So the word rest is a keyword. So the initial velocity right here is 0. The acceleration is 2 meters per second, and the time is, so your givens are, those are your given quantities. Then moves at constant speed for 10 seconds. After this point, then it moves at constant speed for 10 seconds, then decelerates at 1 meter per second square to stop. To stop means the final speed gonna be, the word stop is a keyword here, right here too, and the final speed here is finally when it stops is 0, and deceleration means negative acceleration, that is -1 meter per second square. Find the distance s1 for the question is find the distance s1 for the acceleration phase, the first phase, distance s2 for uniform speed phase, distance s3 for the deceleration phase, and the total distance is traveled by the car just before it stops. And assuming that the car starts decelerating to avoid bumping to an obstacle which is 55 meter from where the driver started to brake his car. Comment whether the driver is safe to avoid accident or not. Also show the motion of the car graphically. Also show the motion of the car graphically and calculate the total distance from the graph. That's from it means that's from the graph. So this includes all the problems that you are going to cover or you will be asked in grade 9 physics linear motion type problem. So you don't need to solve several problems, just go ahead and look very closely to this problem, how I solve it, and I'm going to give you the problem that you are going to practice the same type of problem at the end of this chapter, and just practice, see it, meditate on the problem, just try some calculations. Sometimes you might be asked to calculate distance, sometimes, and the rest are given. Sometimes you will be asked to calculate distance, and sometimes you might be given a distance and need to calculate acceleration or velocity, final velocity, initial velocity, or you might be given final velocity and initial velocity and the time covered for this change, and you might be asked to calculate the acceleration. So those are the problem types you have to understand. You understand? You might be given something and you might be asked the other, or vice versa. So just keep on taking a closer look on this kind of problem. Let's go ahead and solve the problem. Okay, for the acceleration phase, given acceleration is equal to 2 meters per second, initial speed is because the car started from rest, initial speed is equal to 0, time is equal to 5 seconds. Then S1, initial speed is equal to 0 since it started from rest. Since S1 is equal to what? Distance. Solution. We have a distance formula. What? If you have this is the distance formula for acceleration. This is the distance formula. Hold on 1 second. Solution. Use this formula. Is acceleration formula. Distance is equal to ut plus half at square. See, which is equal to what is u? The initial speed. This is 0 because initial speed is equal to 0. Plus then half at square is equal to half times what's a 2 square. 2 times t is 5 square is 25. So 2 by 2 cancels, the distances covered is 25. So S1 is equal to 25. The answer is 25. So distance 1 is 25. So the next one is for uniform phase. For uniform motion phase or S2 is equal to ut, that is vt, velocity times time. But what's v? But v is equal to the final velocity of the initial domain is the acceleration phase. Acceleration phase final velocity will be the velocity for the uniform phase. V is equal to u plus at from the first from the acceleration phase, which is equal to v is 0 plus a is 2 times t is 5, which is equal to 10. So use this 10 inside this. So 10 times t is distance, the time moved for the uniform motion is given to be 10 seconds, which is equal to 100 meter. So 100 meter is for the uniform motion phase. Then S3 the deceleration phase, for this deceleration phase or S3 is equal to given what is given a is equal to -1 meter per second square, v is equal to 0, what's u is equal to 10 meter per second, the initial speed. This is the initial speed, this is the final, because it stops means v is equal to 0, final speed is equal to 0. So in this case, distance will be calculated by this formula. Distance is equal to v final square minus v initial square, or u square, we call it u, over 2a. This is v square minus u square over 2a. You get v is 0 minus u square is minus 10 square over 2a, means minus 2 times 1, because acceleration is -1. Then this is minus 100 over -2, which is equal to 50. Then S total distance is equal to how much was S1? Okay. So the distance is the total distance. S1 is equal to S1 plus S2 plus S3 is equal to 25 plus 100 plus 50 is equal to 175. So the last question says, if when the car holds the brake, to avoid from bumping some kind of obstacle which is 55 meter away from the vehicle by the time he was holding the brake, the driver gonna avoid the obstacle for avoid an accident. Comment on it. That's what the other question says. Yeah, because this one is 50, the obstacle is 55 meter from from the distance from where the driver uh, hold the brake. So there is a 5 meter gap before it stops. So he is safe. So safe. He's safe. There will not be no obstacle, the accidents that are going to happen. The other one is the graphical representation of this problem. Let's see here. Things here. Let's see here. Here. About here. Yeah, this is a graphical representation of uh, the motion. This is the velocity in the y-axis direction. This time on the other x direction. So uh, the car starts from from rest here and moves for 5 seconds with acceleration of 2 meter per second square. So acceleration is equal to 2 meter per second square. 2 meter per second square. So if the initial speed is 0, u is equal to 0, and if t is equal to 5, then b final is equal to, acceleration is equal to 2 meter per second square. B final is equal to u plus at is the formula to find out this point right here, the distance here after 5 seconds. So 0 plus a is 2 times the time is 5, so it's going to be 10. So this value is right 10. This value right is 10 meter per second. So 10, 5 is this point. Then it moves for another 10 seconds with this same form. The speed end decelerate with -1. Slope of this line is -1. It decelerates. When you calculate the same way, this is going to be the time to stop is, the final speed is known. The time to stop is, because acceleration is equal to v final minus v initial over changed on time, or you call it, sometimes you write it as u. So since final speed is equal to 0, 0 minus initial speed is 10 over t is equal to -1. So when you calculate this one, crisscross, minus 10 is equal to 0 minus 0, 0 minus 10 is -10, times 1 is -10, t times -1 is -1, minus t. So 10 is equal to t. So the time to stop that the car covers, the time takes the car to stop from here is 10 seconds. So it has been 15 seconds here. So it's going to be 25 seconds before it stops. So to calculate total distance covered by the car before it stops, what you need to do is you need to calculate the area of this triangle first. That's half times the first triangle, right? Half times base times height. And the second one is this one right here is base times height. That's rectangle. The other one is again half times half times base times height, another triangle. So adding all those triangles, you can go ahead and calculate. It should come, the result should come 100, should come 175 if you solve it graphically. So this is how you solve graphically. And when you go to the problem that I give you to solve, let me give you the problem and that ends our session. Here is the problem. One second. Practice problem. What says? It says a practice problem says, in summary, practice problem: a cyclist accelerates at 1 meter per second for 6 seconds. This is acceleration phase. Then moves uniformly for 12 seconds. Then decelerates at 0.5 meter per second square. This is negative acceleration. Find the total distance. The same problem, the same sheet. You can solve it easily. So leave me your answer in the comment and I'll put the right answer after you guys try to solve this problem. Then, in summary, you have to understand what scalar and vector quantities are in this problem, in this tutorial. I hope you understood everything. What uniformly information and linear motion and uniformly accelerated linear motion is. You also have understood formulas for motion. The other thing is how to convert units and what are derived and fundamental units are. The last one is the graphical interpretation of velocity time graph and calculation of distance from graph and what velocity time graph does mean. Thank you for watching. This is Gideon again. If you have any kind of comment or question concerning this tutorial, you are very welcome. Thank you all for watching.